So an example here, 30 is equal to 6 into 5. Now what does factors mean? Factors means a part of it. A part of it, which means you were to break down 30 into a fashion with whatever number you get, whatever part you get. If you divide 30 by the same number, it should completely be divisible. Now what is an expression? We saw in the earlier chapter, for example, 6xy would be an expression. What could be the possible factors here? Now if we compare with 30, 30 had 1, 5, 6 and 30. Here it will be 6. Why? Because if you divide 6xy by 6, you still get a number which is xy. You can have x as a factor, you can have y as a factor, you can have 6x as a factor, and you can have 6y as a factor, and you can have 6xy as a factor. Why do I say that? You take 6xy, which is the number here, and you divide that with any one of these. Will you get complete division of that number? The answer is yes. So how many factors did we find? 1, 2, 3, 4, 5, 6. So we can find the factors of an algebraic expression. Now imagine if this is an algebraic expression 6x plus 12. Now technically this should be called as a binomial. Why? Because this is one term and this is another term. How do you find the factors of this? The best way to do it is whatever is common here in this term and this term, there is no x here. So naturally whatever you can pull out is 6x plus 2. Can I say that 6 is a factor? X plus 2 is a factor, and can I say that 6 into x plus 2 is a factor? The answer is yes. So how many factors did we find? 3. Now what is a regrouping of terms? If this were the algebraic expression, where this is a polynomial, one term, other term, third term and fourth term. Now if we were to regroup the terms, how would we do that? So for example, I can say that if I were to find the factors here, I can take y common here. Y is the common term and 3x plus 5, and I can say that plus 1 into 3x plus 5. Is that the right grouping? Yes, this is one way of doing it. Can I say that 3x plus 5 is common here? Can I pull it out? And I said, can I say that y plus 1 becomes the other factor here? So what are the factors? 3x plus 5, y plus 1 and 3x plus 5 into y plus 1. Which is the other way of regrouping it? Now can I say that I will group the x terms together? y plus 5, because I thought okay 3 gels well with 3 and I'll take x also common out. So I will say that 3x into y plus 1 here plus 5 I will take out and I'll say y plus 1 here. Can I say that I'll take y plus 1 common here? So y plus 1 becomes common here, and I say that this 3x plus 5 becomes another term here. We solved a similar fashion, but we regrouped the terms here. So regrouping is something which comes by practice. Identities are expression that we have studied, we have formulated and we have proved. For example, the first one, a plus b the whole square. Yes, we have seen that and we have proved it. A minus b the whole square, and a plus b into a minus b, which comes out to be a square minus b square. These are the identities which we have already proved it. Can we use them to factorize a algebraic expression? For example, if this is given to you, would you do something drastically here? What would you know here? You would know that this is 7p square minus 6 square Now what would you do with this? You know that this is similar to this identity. Should I use this identity and write it in this form? So the answer would be 7p plus 6, 7p minus 6. Can we say that 7p plus 6 is one of the factors, 7p minus 6 is another factor? Both merged together is the third factor? Yes. So that is how we make use of the above identities. So division of an algebraic expression. Now assuming we had a number like 100 and you divide it with 5. What is the answer? 20. So this is a integer, you divided with another integer and you got an answer. Can we say that 7x y square divided by 3y, one algebraic expression divided by another algebraic expression? Can we solve this? What do? We say we remove the like terms here, y, and this is, we removed one y here, and the answer is 7x by 3. So we are dividing the algebraic expression. Okay, so which are the various algebraic expressions that we will see for division? Now let us look at this. A monomial will be divided by a monomial, a polynomial will be divided by a monomial, and a polynomial will be divided by a polynomial. Let us take a monomial getting divided by a monomial. It's minus 20x raised to 4 is divided by 10x square. How do we write it? Write it as, can we reduce the like terms, x raised to 4 minus 2, why? Because this 2 goes up and that becomes minus. So the answer is minus 2x square. Okay, so polynomial by monomial. What is a monomial? It's one term. What is poly? It's more than one. How can I do? Can I find the factors of the above polynomial? What I can see here, I can only get y as common here because I don't have any number 6, 5 and 4. I can't get anything out beyond 1. So can I say that y is out 4y square 5y plus 6 divided by 2y. Can I reduce the like terms? Y. Why? Can I say that the answer is? This is how you do the division of polynomial by monomial. Okay, so the below one is also a polynomial more than 1 and the above one is also a polynomial which is more than 1, which becomes 3. Can I find the factor of the above quadratic equation? You split 10 into such that 5 into 2. Those two factors, which is 5 into 2, when you add them up, does it give you 7? Yes. So the factors are 5 and 2 of 10. Can I say that? Can I find factors out of the y square and 5y? So that becomes y and y plus 5. Plus, can I take 2 common out here? So that is 2 into y plus 5. What did you do here? You did regrouping here. You could have placed 2 here, you could have placed 5 here, but it's purely judgmental and you thought, okay, this was a better way to do it. Divided by y plus 5. Can I say that this is equal to y plus 5? I can take this common. And can I say that multiplied by y plus 2 divided by y plus 5? Y plus 5 will get cancelled. So what's the answer? Y plus 2. So we saw how a polynomial can be divided by another polynomial in an algebraic expression. So thank you very much.